welcome to this experiment. I have some keys here, some spare keys that I wanna test regarding rust and aging. This experiment is triggered by a recent comment from PapaGleb to one of my videos. So he said brass keys are just okay as they do not rust, which is true of course, and it's unlikely that they will wear out through all their life. And when I bought keys in a hardware store, the guy told me that steel keys are actually much better because they do not suffer from heavy usage. So I was just curious what rust or what aging could do to my keys. And so I sorted them out. So from my spare keys, I took one of each type, and I will make a test now over some days or some weeks. I will attach them on this board, and then I will make them wet with salt water and let it dry and bring salt water again onto those keys, and we'll see if they rust actually. So I'll start by showing you the keys. So I have one CES key, one ISEO key. That's from Mr. Minute, just a replacement key made from a blank, so I would say a generic key. Then I have a DOM and BKS. What do we have here? Trelog. Then this is Fana. It's made in Poland. It's a brass key actually, as you can see. Then we have a Chichi, and this is a Gera. Then we have another generic one. And we have one made in China. And last one is Forel by Toya, which is also a Polish brand. Some of them are steel. Let's see. This one, the Chinese one, is steel. The generic one is also steel. The DOM is steel. Wow. The Mr. Minute one is also steel, and the others are non-magnetic at least. So yeah, let me just get to my tools, and then I will attach them on the board. Just hold on. Okay, so now here I have my water. Put some salt in it, just to increase the speed of aging. Okay, make it really good wet, and cover the keys. So, and once a day I will remove it and let it dry a little bit, and every night I make a picture, and then we will see how it changes. So hold on until the next day. As time goes by, you can see that a lot of rust has already been created from the keys. So this wet rag is full of rust from the keys. And when we now have a look at the keys, we will see that they are gone. Yes, they are gone because this wooden board was not appropriate for a long-term water treatment. So they started coming apart, and the glue didn't stick to the sweatboard, and so I changed my mind and I took them away and put them on a plastic card. And also to increase the speed of rust creating, I now have them constantly in water, as you can see here. And hopefully we will see now, or we will get an increased speed of rust and aging. So the experiment is over. 4 months have passed and you see the empty container and the remainders of the rust from the keys. And first we'll have a look at the keys, how they have developed within 9 days. I was pretty surprised that after 9 days the steel keys have shown so much rust and the brass keys have shown so least impact. And so I just let them in the water and refilled sometimes the water, and here we are after 4 months of watering. We can see the final result. So from the surface here you see that some kind of dirt or dust have covered everything, and that's not what I was after. So I cleaned the keys up a little bit, but the result is very very clear. So you can see the 4 steel keys here, they have rusted a lot, and here for example the DOM, the steel keys are covered with they are coated so that they actually do not rust, but if you scratch it like here, of course water has a chance to get in contact with the steel and it rusts. And at the bidding, that's actually the biggest problem, I think, because there is no coating, and if it's rusting there, it changes the bidding. So if steel rusts, it grows, so material grows, and if you scratch it away, it take away material. So whatever you do, you change the bidding a little bit at least, and there is of course then a chance that the key won't work afterwards. Yeah, so that's one steel key. Here is another one, Mr. Minute, heavily rusted. That's the back, black color here. Don't know how this could have developed, but I think this is some kind of chemical reaction with the salt water and the coating. Here we have another example. And the last. And you can actually scratch away the dirt here, and I think if you take away this dirt, the coating is still intact and nicely protects the key. But at the area where coating was not there, you have of course a lot of rust. Yeah. For the other keys, here are two brass keys, so pure brass without coating. They actually looked like that before, and now they have changed the color. I mean, they're also covered with this dirt, but if you take it away, you can see brass changes its color when it's getting older or when it's getting in contact with water, and it looks almost like a patina. But no change to the bitting here. They're in pretty good condition. Same with the Chi-Chi. More like a patina than ugly change of the surface. So not so bad. And here are the other keys, which are made from brass and coated. So there's the Iseo. If you take away the dirt, it's almost like before. The BKS. Also not too bad. Oh, nice. Yeah. Zegera. Interesting shading here. And the CES. You can see they are made from brass. Very nice. Very interesting. We have the Forel. It's almost like the Iseo. Yeah, if you take away the dirt. It actually survived the water treatment pretty good. Here the Trelock. Trelock was an old key, as we can see from heavy usage. The coating has vanished on some parts, and here the brass is exposed from by the water and changes its color to brown. But the rest is very good intact. Yeah, that was my non-scientific key rusting experiment. I hope you enjoyed it, didn't dislike it too much. I know some of you really like keys, and I'm sorry that I have done bad things to keys, but yeah. I hope you found it interesting. Yeah, that's it. Thank you very much for watching. Happy picking. Bye bye.